Here we go. So
how do you not get a class?
She has a class. She's full of it. We are going to move into absolute value stuff. What is absolute value?
It's the absolute value. The value that's absolute.
It is. Absolute value is always the distance from zero, right? So when I say, like, what's the absolute value of x? If I say the absolute value of x is 10, for instance, okay? Your options for what could go here are 10 and negative 10. In other words, what is 10 units away from 0? Well, if you go to the left, you're going to get a negative 10. If you go to the right, you get a positive 10, right? So absolute value is just taking the positive and the negative value for that variable, okay? So here's what you're going to be doing. If I say the absolute value of x plus 2 is 9, okay? The rule is this. Hear me, every single one of you right now. Put your iPads away. Pay attention. When you are doing the absolute value of something, you cannot give the two answers until you have isolated the absolute value, okay? In other words, you cannot give the two answers until whatever's in the bars is by itself, okay? Right now, there's this plus 2 with it. So what you're going to do is you're going to take away that 2, just like you're solving an equation, and then we have the absolute value of x equals 7, okay? Now you can do the two equations. So if the absolute value of x is 7, what are my two answers?
X equals
7 and not 9. What is 7 units away from 0? If this is 0, I could go 7 here, or I could go negative 7 here, okay? So when you get absolute value of x equals something, that something as, excuse me, do you need to move? Then quit. When I get the absolute value of something equals some number, your answer is the positive and negative of that number, okay? So if the absolute value of x equals 7, then x could be 7, or x could be negative 7. In other words, I could plug a 7 or a negative 7 in for that x, and it would still equal x, because when I take the absolute value, it's a positive distance. Questions on that?
Yes.
Yeah, right. So we're trying to say, what is x, right? We're trying to solve for x. So if the absolute value of that number...
I thought you were doing 1 times 1 plus 2 equals
No.
9.
Absolute value. Those are the bars. Those are the absolute value bars.
Yeah. That
Okay.
makes so much more sense. Because
Okay.
that's where the 7 comes in and you put, thank you.
Right. Okay. So here's the deal. When you graph that, if x is 7 or negative 7, here's 0. Here's 7. Here's negative 7. X is either 7 or negative 7. No arrows, right? It's an equation. It equals those numbers. It's not greater than, it's not less than, it's equal to. So there are no arrows. Does that make sense? Okay. Yeah, because it's equal to. So if I said the absolute value of y plus 3 equals 9, what do? Subtract 3. You want to isolate your absolute value. So you get the absolute value of y equals 6. Now what do?
You do negative 6 and then put it on the
What's your answer, though, before you graph it?
y equals 6.
Or
Or negative.
negative 6, okay? So you get two answers, 6 or negative 6. So when you graph it, 0, 6, and negative 6, it could be here or it could be here. 6 units away, 6 units away. Okay? Second example. Now we have 2x minus 5 as an absolute value. Okay, these are your absolute value bars. Equals 13. Okay, now what I said earlier, Elijah, put it away. I want you to pay attention to this. What I said earlier was you cannot solve an equation until the absolute value is isolated. Is there anything outside of the absolute value on the left of this equation? No, it's all inside. God bless you. Okay, so what you do is once you've isolated, you set it equal to the positive and negative of whatever our answer is. Okay, so what you do is take away your absolute value bars. God bless you. One of your equations is this exact equation with these taken away. So you get 2x minus 5 equals 13. Okay? So in other words, this right here can equal 13, or it can equal what? Negative 13. Okay? So once you've isolated, you take it equal to the positive, and you take it equal to the negative of that number. So you would say 2x minus 5 equals negative 13 as well. Okay? You have to solve both of those. So when we solve, you're going to add 5. So I get 2x equals 18. Divide by 2. So x equals 9. Okay, but then you have to solve the other one also. Add 5 here. Here's where you have to be a little bit careful. You have a negative 13 plus 5. Why what? Because it's absolute value, right? Absolute value can equal the positive or the negative. So you set it equal to the positive here and the negative here. Okay, so negative 13 plus 5 is negative 8. You have 2x over here. You divide by 2. So x is negative 4. Okay, so your options for this are x equals 9 or x equals negative 4. When you graph it then, here's 0. Here's 9. 1, 2, 3, 4. Here's negative 4. Okay, your answers would be negative 4 and 9. Okay, and you can always double check that. If I plugged it back into my original, the absolute value of 2x minus 5 equals 13. 2 times negative 4 is negative 8 minus 5. So that's the absolute value of negative 13. Well, the absolute value of negative 13 is 13, so that checks out. Same if you plugged in a 9. 2 times 9 is 18, minus 5 is 13. The absolute value of 13 is 13, okay? So you have to set it equal to the positive and the negative. Are we clear on that? A lot of people do this one wrong. Okay, set it equal to the positive and the negative. Okay, keep in mind, absolute value represents a distance, right? It's the distance from 0. Can you have negative distance? You can't. You can run backwards, but you're still running 20 feet backwards, right? As a positive. So just keep in mind, absolute value, if it comes out to a negative, there is no solution, okay? And I'll show you that in just a minute. I want to show you this one. This is like example 4 in the book. It looks like this. This one's a little fancy. 3 times the absolute value of 2z plus 9 plus 12 equals 10. Okay, now we said the rule is you have to isolate the absolute value. Is it isolated right now? No. You have a 3 outside of it, and you have a 12 outside of it. What should I get rid of first? What? The 3 or the 12? You don't want to combine them because this is what it's doing, right? Think of this kind of like parentheses. It's saying 3 times that plus 12, right? But it's not parentheses. It's absolute value. So 3 times something plus 12 equals 10. You kind of think of it like this. 3x plus 12 equals 10. What would be the first thing you'd get rid of there? The 12, right? We would take away the 12. So that's what we're going to do here. We're going to take away the 12. So you get 3 times the absolute value of 2z plus 9 equals 10 minus 12 is negative 2. Okay? Is my absolute value isolated? No, we still have the 3, right? And we said that 3 is being multiplied. So how do I get rid of the 3? Divide it. So we're going to divide by 3. So this is gone. And I get the absolute value of 2z plus 9 equals a negative 2/3. Okay? Now at this point, we have isolated. This is when technically you would set up the 2 equations. But here's where like red lights should be going off. Warning, something's wrong. Because we just said that the absolute value of something equals a negative. An absolute value cannot equal a negative because it's a distance, and distance is positive, okay? So when you get to this point in a problem, if it's just absolute value on one side and a negative on the other, you have to say no solution, and you're done. There's nothing else to solve. You leave it at that. Okay, so once you isolate, if it's negative, no solution. Questions on that? Okay, what do you do with this? The absolute value of 3x minus 2 minus 9 equals negative 4. Okay? Is this no solution? Looking at it right now, would you say that's no solution? Not yet, right? Why? It's not isolated, right? We have to isolate first before we can make that decision. So how do I get the absolute value on the left by itself? No. You want to get rid of that minus 9. How do I get rid of it? You add it. You're going to add the 9. So plus 9 here and plus 9 here. You get the absolute value of 3x minus 2 equals, because this canceled, negative 4 plus 9 is 5. Is this no solution? It's not, right? Because we've isolated and now it's positive over here. So it's not no solution. Now we can solve it. So once the absolute value is isolated, how do we solve it? Take away the bars. How many equations do we write? 2. Whenever there's absolute value, there's 2 equations. So it's going to be 3x minus 2 equals 5. What's the other equation going to be? Equals negative 5. 3x minus 2 equals negative 5. So now it's just a matter of solving those equations, okay? We're going to solve this left one first, so add 2. You get 3x equals 7. Divide by 3. So x equals 7 over 3. You can just leave it as that, or you could turn it into a decimal. You could do 2 1/3 or 2.3 repeating. If you want to do it that way, that's fine too. And then this one, add 2. So you get 3x equals negative 5 plus 2 is negative 3. And then you're going to divide by 3. So x equals -1. Okay, so those are your two answers. X can either be 7/3 or X can be -1, and that will be a true equation. Does that make sense? Okay.
So it's not, this is no solution because the X is on the same.
No, those are both possible answers, because if you plug both of these back in right here where we started, actually right here where we started, if you plug them in there, you're going to get a true equation. It will work out. So they can be different. They don't have to be the same. Just depends how the inequality or the absolute value is set up. Okay? We're going to do two more, and then we're done. How do you do this one? Absolute value of n minus 5 equals -2. Is that no solution? What? We don't know yet. Right now, you can't say no solution. Why? Absolute value is not isolated, right? So how do I isolate that absolute value of n? You add the 5. So I'm going to add 5 to both sides. I get the absolute value of n equals what? +3, right? -2 plus 5 is 3. Okay, so now I'm here. I've isolated my absolute value. Now I write two equations. Take the bars away. N equals 3. And n equals -3. So sometimes they're going to come out to the same number, just positive and negative. Other times they're going to come out to totally different numbers. Okay? Questions on that? Okay, last one. Let's say we have 2 times the absolute value of x minus 1 minus 4 equals 10. Okay, we want to isolate the absolute value. We want to get it by itself. How do I do that? Right, first thing you're going to do is you're going to get that 4 out of there. So you're going to add 4 to both sides. Okay, so we're left over here on the left with 2 times the absolute value of x minus 1 equals 10 plus 4 is 14. Is our absolute value isolated? Not yet, because absolute value is not by itself. There's something else with it. What's with our absolute value right now? The 2, right? The 2 is outside of the absolute value. How do I get rid of that 2? Divide. So we're going to divide by 2 here, and we're going to divide by 2 here. You get the absolute value of x minus 1 equals 7. Have I isolated my absolute value? Yes. So now what do I have to do? How many times? 2 equations, right? As soon as absolute value is by itself, you write your 2 equations. So x minus 1 equals 7. What's the other one? X minus 1 equals -7. So you solve that. +1, x could be 8. Or +1, x can be -6. So those are your 2 answers. Okay? So, key things. Isolate your absolute value. Once you've isolated, write how many equations? 2 every time. The only time you don't write 2 equations is if it's no solution. When is it no solution? If the absolute value equals a negative, right? That's the only time it's no solution. Okay? Questions on that? All right.